I think let's start from 2022. I'm going to be doing 2022, 2023, and 2024, all variants, hopefully. So let's do this. Okay. So it's going to be very similar to the ones I taught you. Let's start. This is Feb March 2022, variant 5.2. We have a group of 12 people, 3 boys, 4 girls, 5 adults. In how many ways can a team, whenever you see team, it's usually combinations. And if you see the word chosen, this is a keyword. If exactly one adult is included. Okay, so we have one adult. So the 4 other adults are excluded. So one adult from the 5, which is 5C1. And from the children, 7 children, you're going to pick 4, which is 7C4. That's it. In how many ways can a team of 5 people be chosen from the group if the team includes at least 2 boys and at least 1 girl? So this is kind of like the one where I taught you about, more women being there compared to men. But rather than that, you have at least 2 boys and at least 1 girl. So the same concept applies. You have to make a table. So it's a team of 5, at least 2 boys and at least 1 girl. This is the bare minimum. So 2 boys, 1 girl. To make 5, you need 2 adults. 3 boys, 1 girl, 1 adult. We have 3 boys in total, so we can't go above that. 3 boys, 2 girls, 0 adults, because they didn't say anything about adults here in the first place. So it's not necessary that we need an adult. Then we have 2 boys, 2 girls, 1 adult, or 2 boys, 3 girls, and 0 adults. So these are all the possibilities. You have to group them up like that, and then just do the basics. 2 out of 3 boys, so 3C2. 1 out of 4 girls, 4C1. 2 out of 5 adults, 5C2. Multiply them and do it for the rest and add up all of them to get the final answer, which is 248. I don't even get my own handwriting, but 120 plus 20 plus 6 plus 90 plus 12. Yeah, that is in fact 248. Yeah, good. Let's move on. Now the same groups stand in a line. Whenever you see a line, like as you associate teams with combinations, whenever you see a line, you should actually consider that it might be permutations. How many different arrangements are there in which the 3 boys stand together and an adult is at the end of the line? So what did I teach you? If some people stand together, they will be considered as one unit. Okay? So the 3 boys are considered as one unit. And other than that, we have 4 girls and 5 adults. The 3 boys stand together and an adult is at the end. So how many units do we have? 1, 2, 3, or 5 adults, 4 girls. So that's 9 units over here and 1 unit for the boys. So in total, that's 10 units. Okay? However, it's a bit tricky because the adults have to be at the ends. No other person, no other boy or girl can be at the end. So look at the blanks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, because there are 10 units. But the adults have to be at the ends. And since there are 5 adults, it's going to be 5P2. And since the adults are unique, that's why it's 5P2. If the adults were not unique, you would have to do a 5C2. Okay? But since they're unique individuals, so it's 5P2. And then in the middle, we have, what else do we have? We have the boys as a unit, then we have 4 girls and 3 adults left. We have 8 units left because we just added these 2 adults down. So 10 minus 2 is 8. So 8 factorial for them, since everyone is unique. And the boys can interchange in between them. So it's 3 factorial for them. So this was a pretty complicated sum. See if you guys get it. Okay, see if it makes sense. It is basically 5P2 because 2 out of 5 adults have to stand on the end and they are unique, so their arrangement matters. And then 8 factorial for the units in the middle. The 3 boys as 1 unit and the 3 remaining adults and 4 girls, that's 8 in total. And 3 factorial for the boys, they can be interchanged as well. Okay, Moving on to May June 2151. Question 1 and 2. Let's do this. Find the number of different arrangements of the word deceived. So as you can see, what did I write on the right hand side? I wrote it down like DD, triple E, 1, 2, 3, and then CIV. So we have 1, 2, 3, 4, 5, 6, 7, 8 letters in total. So that's all arrangements. Total arrangements is 8 factorial divided by 2 factorial times 3 factorial for the repetitions. So, but that's not what they asked. They asked in which all 3 E's are together and the 2 D's are together. All 3 E's are together and the 2 D's are together. So, how do we do this? All 3 E's are together. So, for that, we have 3 factorial by 3 factorial. How many units do we have in total? CIV, 3 units. And then these are individually 1 unit each. So we have 5 units in total. So for that we have 5 factorial. And then for the D's, it's 2 factorial by 2 factorial. And then for the E's, it's 3 factorial by 3 factorial. But this part is totally optional. You can choose to not write this at all, and then it would still be fine. Okay? Do you guys understand? 120. Find the number of different arrangements of the 8 letters in the word deceived in which the 3 E's are not all together. Okay. So this is very important. This is what I taught you today in the beginning, in which the 3 E's are not all together. What does that mean? The E's can be next to each other. Like there can be 2 E's next to each other, but the only restriction here is that 3 E's cannot be all together. So in this particular sum, the only way to do this is you have to find out the total number of ways, which I told you already is 8 factorial by 2 factorial into 3 factorial, and then subtract the number of ways in which all the 3 E's are in fact together. Then you will get this answer. Okay. So how to do that? Check this. You have D, D, C, I, V, and then you have 3 E's. So how many units do we have? 1, 2, 3, 4, 5, and then 1 unit over here. That's 6 units. So 6 factorial for that. However, since you have 2 D's that are repeats, we are dividing that over here. 6 factorial by 2 factorial. And for the E's, it's 3 factorial by 3 factorial, which is again optional. So this is the number of arrangements where the 3 E's are all together. Now if you subtract this answer, 360, from 3360, you're going to get your answer where you get all the arrangements where the E's are not all together. And if they ever said where the E's are not next to each other, you would apply the arrow method, which would have been DDCIV. In the arrow method where they are not next to each other, I told you, you ignore the ones that cannot be next to each other. You input the other letters, which is 5 factorial by 2 factorial, and then you have 1, 2, 3, 4, 5, 6 arrows. So that's going to be either 6p3 divided by 3 factorial or 5 factorial divided by 2 factorial into 6c3, because the E's are identical anyway, so the arrangement doesn't matter. Okay. Next. Let's do this. There are 6 men and 8 women in a book club. Now, the committee of the club consists of 5 of its members. Mr. Lan and Mrs. Lan are members of the club. In how many different ways can the committee be selected if exactly one of Mr. Lan and Mrs. Lan must be on the committee? So, either one. So, let's do this, but not both. So, I chose Mr. Lan, which is 1C1. And how many people do we have in total? 6 plus 8, which is 14 people. But I chose Mr. Lan already, and Mrs. Lan can't be on the committee. So we are going to go with 12 people. Out of 12 people, I have to choose 4. And for the other one, I took Mrs. Lan in, which is 1C1. And from the remaining 12, because I have to exclude Mr. Lan, it's going to be times 12C4, which is 12C4 times 2 or 990. The other way is you can find out the total number of ways, which is 14C5, and then subtract two committees from this. One where we have both of them, and one where we don't have either of them. So the one where we don't have either, we exclude those two and we choose 5 from the remaining 12. And the one where we have picked both of them, which is 1C1 times 1C1, and for the from the remaining 12 we pick 3. But I prefer this method more, it's much better. In how many different ways can the committee be selected? Combinations again. If Mrs. Land must be on the committee and there must be more women than men on the committee. Okay. So more women than men. As you can see, we did this type of sum. Make a table. And women, men. 3 women, 2 men. 4 women, 1 man. And 5 women, 0 men. But there's another condition. Mrs. Land must be on the committee. Okay. So Mrs. Land is already included. So that's 1C1. She's always there. Okay. She never misses. And from the 4 people, we need more women than men. So 4 women, 0 man, 0 men. 3 women, 1 man. And 2 women, 2 men. Why is this possible? Because we already have Mrs. Land. So she's actually adding one more to the woman over here. So from the woman, which is 7, I'm taking 7 women because I have already taken Mrs. Land. From the 7, I'm picking 2 women. And from the 6 men, I'm taking 2 men. Here, we don't talk about Mr. Land because that was the condition in part A, not the condition in part B. So it doesn't really matter here. So yeah, then we take 3 women from the remaining 7 and 1 man, and then 4 women from the remaining 7 and 0 men. Okay, so if you add all of these up, you are going to get your answer 560. A bit complicated. Next, moving on to Major 2022-52. This was a hard sum actually. The sum over here, we have a word crocodile. So crocodile. So you have the word. This is Major 2022-52. Paper 52. You have CC double O then RDILE. I wrote the word like that. All arrangements. So you have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 letters divided by 2 repetitions. 2 factorial for C times 2 factorial for O. 90720. Next. Find the number of different arrangements of the 9 letters in crocodile in which there is a C at each end and the 2 O's are not together. Important. So whenever I tell you that the 2 O's are not together, since there are 2 letters, it actually has the same meaning as the O's are not next to each other. Same meaning. So whenever you get that, you ignore that letter completely. Do you get what I mean? You ignore that letter completely. Okay, there's a lot of working here, but it doesn't matter. Let me simplify things for you guys, okay? It won't take long. There's a lot of working here for some reason. Okay. So crocodile, right? I ignored the O's. C C O O R dial. I'm ignoring the O's for now. So how many blanks do we have? 1, 2, 3, 4, 5, 6, 7. I put the C's at the ends. So for them, it's just going to be 2 factorial by 2 factorial, or you can ignore them because they're the same thing. Next, R dial. R dial is going to be at the center. RDILE. So that is 5 letters, which is 5 factorial, unique. And now for the O's, check this. The O's cannot be next to each other, so they will be in between these letters, but they cannot be at the ends either. So I've taught you this, so we skip them. So you have 1, 2, 3, 4, 5, 6 spots. Okay, so 6 spots, so 6 C2 because they're identical, so you don't need permutation. Or you could go for 2 factorial by 2 factorial into 5 factorial into 6p2 by 2 factorial. Same thing. Okay, it doesn't really matter. It doesn't really matter. Okay, it's that 1800 is your answer. And I told you that when you have two letters, you can actually opt for the other method, where you can keep them together and then subtract from the total number of possibilities. That is also possible. So the total number of possibilities here is a bit different because the C's have to be at the ends, and this is a condition. So I keep the C's at the ends, and in the middle we have 7 letters, R dial plus 2 O's, that is 7 factorial by 2 factorial in the middle. And then if you keep the O's together, how many units do you have? 5 for R dial, and the 2 O's will be considered as a single unit. So 6 units, 6 factorial times 2 factorial by 2 factorial, because the O's are in fact identical, and you can ignore that. Okay, and then if you subtract 6 factorial from 7 factorial by 2 factorial, you'll also get 1800. But personally, I don't prefer this method. Whenever I see that two letters are there, or if I see the wording that these letters cannot be next to each other, I always apply the arrow method. Okay, that's my word of advice for you guys. Next, 4 letters are selected from the 9 letters in the word crocodile. Personally, this is one of the hardest questions in my opinion. This C and D, and a lot of people have been saying that maybe there's a mistake in part D in the mark scheme, like maybe it should be 65, like the mark scheme has been updated or something. If anyone knows, please do comment below if you have the updated mark scheme. Okay, yeah, so find the number of selections in which the number of C's is not the same as the number of O's. Fine. So for this type of sum, you also need to make a table. We are making a selection of 4 letters. Okay. As you can see, we have 4 letters over here. Then the no restrictions, but the number of C's is not the same as the number of O's. So it can be 0C, 1O, 0C, 2O, or 1C, 0O, 2C, 0O, or even 1C, 2Os, or 2C, 1O. The number just can't be the same. Like it can't be 0, 0, it can't be 1, 1, it can't be 2, 2. These are the red flags. Okay? So I just input that over here. 1C, 2O, 2C, 1O. Then we have 1, 2C, 0O, 2O, 0C, 1C, 0O, 1O, 0C. Okay, so 1, 2, 3, 4, 5, 6 of them. And for the remaining blank, we have to input R dial inside, R dial. So that is basically, for here it's 5C1, 5C1, 5C2 over here, and 5C3 for these ones, basically, yeah. So in total, we have 50. So that's that. Now let's move on to the next one. Find the number of ways in which the 9 letters in the word crocodile can be divided into 3 groups, each containing 3 letters, if the 2 C's must be in different group. So this is a rather difficult variation, which is pretty rare. I haven't seen this much. But yeah, a lot of people have been saying that the mark scheme has been updated and the new answer is 65 rather than 80. So if you guys know where to get that, please do comment down below. Like, I don't think you can comment down links, but just tell me the website where I can get it if the mark scheme has been updated. Because a lot of people have been saying that this 30 should be 15 and the total should be like 65 or something like that. Okay, so let's try to figure this out. So we have to divide crocodile into 3 groups. So there are 9 letters, so if you divide it into 3 groups, it's 3, 3, 3. Okay, so each group containing 3 letters, if the 2 C's must be in different groups. So okay, I'm calling it as group 1, 2, 3. So in the first one, I'm keeping group 1C, in the second one 1C, and in the third one 2 O's. And then we can keep 1 O with each C, 1C, 1 O, 1C, 1 O. And then we can keep 1C individually, like alone, then 1 O with 1C and another O alone. And then for the last one, 2 O's with a single C, and then we have 1C alone, and in the third group we don't have anything. So these are all the possible combinations that I've written down over here. So as you can see, you can check this out. Okay, these are all the possibilities. Now I just divided them up in the groups. So over here we have 4 variations. 1C with both O's, 1C alone, nothing. 2 O's alone, 1C individually. Then an O with each C. And then finally an O with a C, 1 O alone, 1 C alone. Okay. And we have R dial. Okay. So if you put R dial in, what will you get? It's 5C2 times 5C3, or the other way around, 5C3 times 2C2, or 5C2 times 3C3. You get 10. And then here you get 5C1 times 4C2 times 2C2. Okay. And then in group 3 you get 5C1 times 4C1 times 3C3, and in group 4 you get 5C1 times 4C2 times 2C2. So here's the thing though, in group 2 and 3, do you see a resemblance? Like these two groups are identical, and here also these two groups are identical. So due to there being identical groups, and this is the combination, that's why we have to divide by 2 factorial, because this is the same thing. So probably there should be a 2 factorial down over here as well, and this should be 15, and the total should be 65. This is what I said while solving this paper in my channel. But yeah, in the mark scheme that I linked in the description, I do have 80 given, but I personally think it should be divided by 2 because it's the same group. So if you guys get an update, please do comment below, and I'll then update the description in my original video. But yeah, it should, then if you add them up, you get the final answer. But it's very rare. This is the first time that a question like this came in the first place. So yeah, that's that. Anyway, let's move on to Major 2022 5.3. Question 7. A group of 15 friends visit an adventure park. The group consists of 4 families: Mr. and Mrs. Kenny and their 4 children, Mr. and Mrs. Lizzo and their 3 children, Mrs. Martin and her child, Mr. and Mrs. Nantes. The group traveled to the park in 3 cars, one containing 6 people, one containing 5 people, and one containing 4 people. The cars are driven by Mr. Lizzo, Mrs. Martin, and Mr. Nantes respectively. In how many different ways can the remaining 12 members be divided? Whenever they say this, the arrangement does not matter. This is what I was talking about when I was describing all types of sums. So the position of Mr. Lizzo, Mrs. Nantes, and Mr. Nantes and Mrs. Martin is fixed. So we have 12 people left. So the cars, how many seats do they have? One containing 6, one containing 5, one containing 4. Okay. So this car has 6 seats in total, but the driver is already there, so you have 5 seats left. Here you have 4 seats left. Here you have 3 seats left. So it's going to be 12C5 times 7C4 times 3C3. Or you could fill this up first. 12C4 times 8C3 times 5C5. You can pick any one. It's just that after you've taken 5 people, you have to reduce the pool by 5. 12 minus 5 is 7. Just make sure you do that. Okay? Any particular pattern works. Next, the group entered the park by walking through a gate one at a time. In how many different orders can the 15 friends go through the gate if Mr. Lizzo goes first and each family stays together? Okay. So Mr. Lizzo will go first. This is the entrance. And in the Lizzo family, we have Mrs. Lizzo and 3 children. So in the Lizzo family, you have Mrs. Lizzo and 3 children. So Mr. Lizzo is the first man. So for the other 4, you have 4 factorial. Okay? And then suppose I take the Kenny family. There any arrangement can be possible. 4 children and 2 parents, so that's 6 factorial. And then for the Martin family, we have only 2 people, so that's just 2 factorial. And for the Nantes family, we have just the parents, so that's 2 factorial. Okay? However, there's another part. There's a 3 factorial. Why? Because the Kenny family, the Martin family, and the Nantes family, they can interchange between each other. Like ABC interchanging between each other, so that's 3 factorial. I'm not taking Lizzo family into consideration because Mr. Lizzo has to be the first man entering. So that cannot be interchanged as the families have to go together. Okay, so this is the general idea. In the park, the group enters a competition which requires a team of 4 adults and 3 children. In how many ways can the team be chosen from the group of 15 so that the 3 children are all from different families? So this is chosen combination. So in how many ways can the team be chosen from the group of 15 so the 3 children are from different families? We need 4 adults and 3 children. So any adult works. How many adults do we have? Mr. and Mrs. Nantes, Mrs. Martin, Mr. and Mrs. Lizzo, Mr. and Mrs. Kenny. 1, 2, 3, 4, 5, 6, 7 adults. So any 4 from those 7 adults, okay? And from the 3 children, we have 4 children over here, so 4C1. 3 children over here, that's 3C1, and 1 child. Mrs. Martin has 1 child, so it's 1C1. So from the Lizzo family, anyone. From the Kenny family, anyone. And from the Martin family, anyone. So if you multiply these, you get your final answer as 420. 1 child from each family. In how many ways can the team be chosen so that at least one of Mr. Kenny or Mr. Lizzo is included? Okay. At least one. That means either Mr. Kenny only or Mr. Lizzo only or both. So we can do something. We can find out the team where Mr. Kenny and Mr. Lizzo are not included and then subtract it from the total number of ways. Okay. So total ways. Any 3 children out of 8 children, 4, 5, 6, 7, 8 children, any 4. And from the adults, from the children, any 3, 8C3. And from the adults, 4, 7C4. That's the total number of ways. Now, number of ways where neither Mr. Kenny nor Mr. Lizzo is chosen. Okay. So the children, right, will be the same. It will still be 8C3. And we're going to exclude both of them from the pool of the adults. So it's going to be 5C4 now. That's 280. Now, if you subtract 280 from 1960, you're going to get the number of ways where you have at least one of Mr. Kenny or Mr. Lizzo. Or both of them, basically, yeah? Or the alternate way is there, which is much more complicated, adding 3 scenarios individually. So I don't prefer that, honestly. Moving on to ON 2022-51. The 15 members are having their photograph taken. They stand in 3 rows. Oh, this starts here. A social club has 15 members, of whom 8 are men and 7 are women. The committee of the club consists of 5 of its members. Find the number of different ways in which the committee can be formed from the 15 members if it must include more men than women. Okay. So, more men than women. So, for example, you need 5 members in total and more men than women. So, 5 men, 0 women, 4 men, 1 woman, or 3 men and 2 women. These are it. These are all the possible combinations. So 8C5 times 7C0 plus 8C4 times 7C1 plus 8C3 times 7C2. These are all the possible combinations, okay? Next, we are going to take a photograph now. They stand in 3 rows with 3 people in the front row, 5 people in the middle row, and 7 people in the back row. In how many different ways can the 15 members of the club be divided into a group of 3, a group of 5, and a group of 7? Fine. So here the arrangement does not matter. We are just dividing them into groups, like the sum with the car, okay? So you can start with any row. Suppose I started with the front row. 15C3 times 12C5 middle row times 7C7. It is the same as starting with the back row. 15C7 into 8C5 into 3C3. You will get the same answer, which is 360, 360. Okay? Next, in one photograph, Abel, Betty, Callie, Doug, Eve, Freya, and Gino are the 7 members in the back row. In how many different ways can these 7 members, we're just dealing with the 7, be arranged so that Abel and Betty are next to each other and Freya and Gino are not next to each other? So a common technique that I tell you guys is that, the ones that cannot be next to each other, completely ignore them. So I am completely ignoring Freya and Gino. They are out of the picture currently. And Abel and Betty, since they are going to stand next to each other, I'm going to consider them as a unit. So Abel, Betty, one unit. And then Kelly, Doug, Eve. So how many do we have units in total? 3, 1. So that's 4 units in total. So for 4 of them, it's going to be 4 factorial. And for Abel and Betty interchanging, because they're unique, we have another 2 factorial. And then now for Freya and Gino. 1, 2, 3, 4, 5. 5 spots, but 2 people. 5p2, because they're unique, so it's 5p2, not 5c2. So always remember, the arrows, deal with them at the end. The ones who cannot stand next to each other, always deal with them at the end, okay? Moving on to ON 2022-52. Oh yeah, guys, if you want access to all of these solved papers with the explanations on the side, you can consider supporting me on Patreon. I'll drop a link in the description. It's just $20 a month. You get access to all my stuff for science, physics, chemistry, bio, and math, as well as P3 and yeah, others. I'm considering launching another tier actually, where you can get access to one subject only, which might be affordable for a lot of guys, because $20 might be a bit too much, but maybe for $5 you could get access to one subject, you know, maybe. So that might help. Anyway, let's start with number 7. Find the number of different arrangements of the 9 letters in the word alligator, in which the 2 A's are together and the 2 L's are together. Okay. So alligator, double A, double L, and Igtor, I-G-T-O-R. So 2 L's and 2 A's are together. So in total, how many units do we have? These 2 A's are 1 unit, these 2 L's are 1 unit, and 5 over here. So 7 units, which is 7 factorial. Yeah, and you can just ignore the rest, because the A's can interchange, but they're the same. So yeah, that's that. Same thing. Next, the 9 letters in the word alligator are arranged in a random order. Find the probability that the 2 L's are together and there are exactly 6 letters between the 2 A's. Okay. So firstly, this is a very complicated sum, because its probability, it consists of 5 marks. So the A's, how many letters are there in total? If you count them, 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 blanks. And then I start with 1 A at the beginning, since then 6 blanks. 1, 2, 3, 4, 5, 6 over here. And then the A will be on the 8th blank over here. And the alternate one for this is, like, the A starts from the 2nd blank and it will be on the 9th one. Only then there will be 6 letters in between. Okay. So this is the possibility for A's. Either the A will be on the first one and the 2, 3, 4, 5, 6, 7, 8th one, or A will be on the 2nd one and the 9th one. In this particular way, you can only have 6 letters in between. Okay. Next. So we just ignored the A's because we put them over there. But since there are 2 roots, I'm going to multiply that by 2. Because I can arrange the A's in 2 ways. Either 1st and 8th or 2nd and 9th. That's that. Next. The L's are together, so they will be considered as a single unit. They will be considered as a single unit. So how do we do this? We have Igtor, right? Let's use a different color. I-G-T-O-R. Okay. So we have 1, 2, 3, 4, 5. So for these 5 letters, I'm giving 5 factorial. Okay. And then for the L's, look, in how many ways can I just input them? 1, 2, 3, 4, 5. They can't be on the end actually, because I only have 1 blank on the end, right? So this 5 factorial is for IGTOR, this 5 is for the number of ways that I can put the L's, and this 2 is for the arrangement of the A's, because the A could also be on the 2nd and last blank. Do you get what I mean? For example, the same thing would apply over here. Look, the L's, they would have 5 spots. Check this. I just want to make things clear for you guys. It could be over here, it could be over here, it could be over here, or here. It's 5 ways for the L's. 5 ways for the L's. For IGTOR, it's 5 factorial. And why do I multiply by 2? Because this thing and this thing, right? Same thing, 5 into 5 factorial, but it's into 2 because the A's have 2 positions. So this is the number of arrangements where the A's are at the ends, and sorry, the A's have 6 letters in between them, and the L's are together. Next, since they wanted probability, we need to divide by the total number of events. So what's that? It's alligator, right? So 9 letters in total, but divided by 2 factorial for the L's and 2 factorial for the A's. So as a result, we have 9 factorial by 2 factorial into 2 factorial. We actually get 1200 by 90,720. Next. Find the number of different selections of 5 letters from the 9 letters in the word alligator which contain at least one A and at most one L. So we need to make a table again. We are selecting 5 letters. So at least one A. So we need 1 A or 2, can't be 0, and at most 1 L. It will either be 1 or 0. So 1A 0L, 2A 0L, or 1A 1L and 2A 1L. Remember, when you have repetitions, you have to deal with them separately, and since we're dealing with them already, you can't consider them twice. I'll tell you what I mean. For example, I pick 1A and 0L, then I completely ignore the A's and L's. I only deal with IGTOR, I-G-T-O-R. I have 4 blanks but 5 letters, so that's 5C4. Then 2 A's and 0 L's, I ignore the L's completely. From IGTOR, I choose any 3, 5C3. 1A, 1L, 5C3. 2 A's, 1 L, 5C2. If you add all of these up, you get your final answer as 35. Okay, so let's move on to ON 2022-53 now. Question 6. Okay, so find the number of different arrangements of the 9 letters in the word activated. So yeah, it's double A. I'll show you. Double A followed by double T, and then we have CIVED. So 9 letters, 9 factorial divided by 2 factorial and 2 factorial for the double A and double T. Next, what do we have? Find the number of arrangements in the word activated in which there are at least 5 letters in between the two A's. So we did a sum like this where there were 6 letters in between the two A's. So let's see this. So 9 letters, right? So 9 blanks basically. 1, 2, 3, 4, 5, 6, 7, 8, and 9. So we need 5 letters in between the A's. So 1 A, then 1, 2, 3, 4, 5. Then the A will be here. So similarly, what other arrangements do we have? Here you go. So there are 3 ways in which we can do this. Second blank and over here, third blank and over here. There you go. So they, in the question, they said at least, right? In the question, they said at least 5 letters between the two A's. Okay, so that means you can have more than that. So this is the arrangement for at least 5 letters. You could have 6 letters in between. Like check this: first blank, 6 gaps, then an A, or it could be on the second one and the 9th blank. And then you could also have 7 letters in between them where the A's are on the first and last blank. So after you input the A's, what else do you have? You have 7 letters, out of which you have 2 T's that are repeats. So basically it's 7 factorial by 2 factorial times 3, because there are 3 arrangements for 5 letters in between. and here it's 7 factorial by 2 factorial times 2 for 6 letters in between, and here it's just 7 factorial by 2 factorial times 1. So after you add up these values, you get your final answer, which is 15120. See if that makes sense. Okay, next, let's check this out. 5 letters are selected at random from the 9 letters in the word activated. Find the probability that the selection does not contain more T's than A's. So the number of A's, the number of T's cannot be more than A. They can be the same but not more. Okay, so we can have 2 A's, 2 T's, 2 A's, 1 T, 2 A's, 0 T, or 1 A, 1 T, 1 A, 0 T's, or 0 of each. This was the tricky one, which a lot of students may have missed out on. Okay. On the other hand, the ones that are not accepted are 2 T's, 0A, 2 T's, 1A, 1 T, 0A. These are the red flags, okay? You can't have those. So we are choosing 5 letters, so I put 5 blanks, and then I just input these, right? 2 A's, 2 T's, 2 A's, 1 T, and so on. 2 A's, 0 T's. There are in total 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so I just input those. Now this sum is a bit different from the ones we've done beforehand, because look at this. Here they're asking for find the probability. Okay, find the probability. That's the important point. So in the previous sums, what was the question exactly? Let me show you. Then we can actually find out the difference. Here, find the number of different selections. So in this particular sum, we did not deal with the A's or L's anymore. But here they said that we are selecting a few letters and then find the probability. So if you ever find a sum like this, then the repetitions do matter. Because here, if we have more than one A available, that will actually have an impact, because we are dealing with all possible scenarios, okay? So what's the difference over here? Obviously from CIVED, we're going to input 3 letters over here. So it's going to be 5C3. However, we are going to take these A's into consideration. What does that mean? Since I've selected 2 A's, it's going to be 2C2. And here, it's going to be 5C2 for CIVED. And here, I've picked 2 A's out of 2 and 1 T out of 2 T's. So that's 2C1. And here, I've picked 1 A out of 2 A's. That's why it's 2C1 and 5C4 over here. So you might be wondering, okay, so why are you considering them here? What's the impact that they have? Like, why didn't you consider them in the previous sum that you did? Okay, you might be wondering this. Sorry. So the general idea is, in this particular sum, the selections, the probability does not matter. So we are just dealing with one particular scenario. It doesn't matter whether the thing will repeat or not. But here, that has impact because we are dealing with all possible events. So obviously, like if you're picking this A, if we consider this as A1, there was a chance that we could have picked the second A2. So that actually has an impact, which is why this probability actually doubles. The number of events doubles. That's the idea. So here we have 1A, so 2C1 times 1T, which is 2C1, and then 5C3, okay? And then here it's 5C1 for CIVED, and 2C2 times 2C2. And the one where we have 0 A's and 0 T's is just going to be 5C5. That's it. So if you add all these up, these are the successful events. Now if you divide by all possible events, which is selecting 5 letters from the 9-letter word, which is 9C5, you are going to get this answer as 43 by 63. So that's that. Okay. So we are done with 2022.